This is the first in a series of videos in which we'll be looking at solutions to the CSEC Advanced Paper 2024, which was, well, yesterday. The exam was yesterday. All right, so we'll begin by looking at question one. Question one, part A says, determine the other linear factors of the polynomial 3x cubed plus 8x squared minus 20x minus 16, given that x minus 2 is a factor. So we'll begin by writing down the polynomial. Let's call the polynomial f of x. So we're going to say let f of x equals 3x cubed plus 8x squared minus 20x minus 16. And what are we told? We're told that x minus 2 is a factor of f of x. Essentially, we're told that. Now, and what are we required to do? We're required to find the other factors. Now, how do we go about doing that? Now, this right here is a cubic polynomial. And of course, x minus 2 is a linear factor. Now, we can use a method of long division. If you were to divide a cubic polynomial by a linear, then of course it gives us a quadratic. And so we can actually find the quadratic factor by the method of long division. And when we get the quadratic factor, we can then try to factorize it. All right, so let's proceed to doing that. So here we have 3x cubed plus 8x squared minus 20x minus 16. Let me just check to make sure I write down the correct expression. Yes. And we're going to be dividing by x minus 2. Right? So what do we say? We say x into 3x cubed, that goes 3x squared. Then we say 3x squared times x gives us 3x cubed. 3x squared times minus 2 gives us minus 6x squared. We draw a line underneath that, and of course we're going to be subtracting that. When we subtract that, of course, our signs change. That becomes negative, this becomes positive. These two actually cancel each other, and we get 8x squared plus 6x squared. That gives us 14x squared. And we can bring down the minus 20x. All right, let's continue. Next, we see x into 14x squared gives us plus 14x. And then, of course, we say that 14x times x, that gives us 14x squared. So we have 14x squared, then 14x times minus 2, that gives us minus 28x. And of course, once again, we're going to subtract that. When we subtract it, of course, our signs change. So that becomes minus 14x squared. This becomes plus 28x. And so these terms cancel. And now we have minus 20x plus 28x. That gives us 8x. Then, of course, we bring down the minus 16. And so we end up now with 8x minus 16. And then we now see x into 8x. That goes plus 8. Then we say 8 times x is 8x, and then 8 times minus 2 is minus 16, right? So this should be minus 16, not minus 6. Let me fix that. So this should be 8x minus 16. And of course, now we're going to subtract. So 8x minus 16, no, I have two sixes. What's happening? Right, so 8x minus 16. Right, so 8x minus 16 minus 8x minus 16 is simply 0, which of course what we expected, because x minus 2 is a factor, and therefore we expect that when you divide the polynomial, the cubic polynomial, by x minus 2, we're going to get a remainder of 0. Okay, so having done that, we can now basically go on to say that our polynomial f of x may be written as 3x cubed plus 8x squared minus 20x minus 16. And this, of course, is equivalent to x minus 2 times the, what do you call it now? The divisor into the dividend, the quotient, times the quotient, which is 3x squared plus 8x 3x squared plus 14x rather, plus 8. So 3x squared plus 14x plus 8. So we've managed to factorize the polynomial. Has it been factorized completely? We're not sure, so we have to check. So let's now focus on the quadratic. So we can basically say, for instance, let g of x be equal to 3x squared plus 14x plus 8. And what this therefore means is that in this particular quadratic, we have a equals 3, b equals 14, and c equals 8. Now, generally, how do we check if a quadratic can be factorized? We basically find the product AC. AC is equal to 3 times 8, which is equal to 24. And we then ask ourselves, what factors of AC also add to give B? In this particular case, we ask ourselves, what factors of 24 also add to give 14? And what are those two factors? Those factors are 12 and 2. So 12 times 2 is equal to 24, and 12 plus 2 is equal to 14. And therefore, having found those factors, we can continue by saying that this is equal to 3x squared plus 12x plus 2x plus 8. So we basically split the x term based on the factors that we found, 12 and 2, right? And we proceed to factorize. We group the first two terms and we factor the highest common factor, which in this case, of course, is 3x. 3x into 3x squared, that gives us x, and 3x into 12x gives us plus 4. Then, of course, for the next two terms, we factor out, in this case, 2, and that leaves x plus 4. And so this quadratic is factorized to give 3x plus 2 times x plus 4, right? And so that is a factorized quadratic, and therefore, in terms of the polynomial, we can now therefore say that our original polynomial, f of x, is equal to x minus 2 times x plus 4 times 3x plus 2. And that is the fully factorized version of the polynomial, right? So that was worth about how much? How many marks? 3 marks. So that was worth 3 marks. And of course, we're going to use that now to look at part 2. Now, part 2 says, hence, simplify the multiplication. So let's jot it down. They want us to simplify the multiplication. Let me just do it up here, yeah. So I'll make some space up here. There's my cursor. I can't see my cursor. All right, so having factorized our quadratic, our cubic polynomial, we can now proceed to doing this part of the question which they want us to prove. So what do they tell us now? They tell us that hence, simplify the multiplication, 3x cubed plus 8x squared minus 20x minus 16 over x squared minus 4 times x plus 2 over x plus 4. Now, usually when you do a part of a question and we move on to the next part and we see the word hence, it obviously means that we're supposed to use the result we just obtained in the previous part of the question. Now, sometimes they may say hence or otherwise, which means that we can actually use some other result or some other method. But in this particular case, we're told hence, simplify, which means that we're supposed to use the previous result. Now, of course, we factorize a polynomial, and we factorize a polynomial to give us x minus 2. The other factor was, of course, x plus 4, and the other 3x minus 2. So this polynomial becomes x plus minus 2 times x plus 4 times 3x minus 2. And this, of course, is being divided by x squared minus 4. Now, x squared minus 4, we should be able to recognize as the difference of two squares. And when factorized, that gives us x minus 2 times x plus 2. And then all of this is being multiplied by x plus 2 over x plus 4. So having fully factorized the polynomial, And of course, the denominator of that particular fraction, we should be able to now recognize that there are certain terms that will cancel each other. So x minus 2 goes into x minus 2, right? Similarly, x plus 2 will divide into x plus 2. X plus 4 will divide into x plus 4. And therefore, what this leaves is 3x minus 2. So this fraction simplifies to give us 3x minus 2. And that is the end of part A of the question, right? So yes, that was part A of the question. It wasn't really very challenging, but obviously under exam conditions means a totally different situation from just doing the question after the exam has gone with no pressure, right? So that was part A of question 1. We'll now move on to part B of question 1. Now, part B, I would have spent a significant amount of time looking at part B, and the reason for it is that there was a point and I thought that I would have made a mistake, and I'll explain why that is in a short while, right? So let's begin by now looking at part B of question 1. Now, part B says the equation, let's write it down, k x squared plus x minus 15 equals 10. We're told that it has roots alpha and beta, right? And of course, we're also told now, pay attention to this part, and this is where my issue is going to come in later on. We're told specifically that k is a whole number. So what this basically means is that k belongs to the set of whole numbers, or we can say k is an element of the set of whole numbers. And this is where the issue is going to come in with this particular question. Now, this quadratic, of course, is in the form ax squared plus bx. Well, let me do something else first, right? Right. So we have a 10 over on the right hand side. So let's bring it across so we can actually put it in the form ax squared plus bx plus c equals 0. So doing that, we get kx squared plus x minus 15 minus 10 equals 0. And therefore, this becomes kx squared plus x minus 25 equals 0. Right, so this quadratic is now in the form ax squared plus bx plus c equals 0. And of course, when we make that comparison between two forms, we should be able to recognize that or a is equal to k, so a equals k, or b is equal to 1, and c is equal to negative 25. All right, so that's what we have so far. Having expressed the quadratic in the form ax squared plus bx plus c equals 0, we identified that a, the coefficient of x squared, would be equal to k, b, the coefficient of x would be equal to 1, and our constant term that is independent of xc is equal to minus 25. Now, let's proceed. Now, what are we told? Of course, they're told the roots are alpha and beta, and they want us to determine expressions for alpha plus beta and alpha beta. So let's do that. So say that alpha plus beta is equal to minus b over a. This is something that you should know. And of course, this is something that would have actually derived in a previous past paper question solution. Now, alpha plus beta is equal to minus b over a. And of course, that would be equal to minus 1 over k. So there is the expression for alpha plus beta. Now, secondly, we want to find alpha beta, which of course we know to be equal to c over a. And so this gives us negative 25 over k. So there we have our expressions for alpha plus beta and alpha beta, right? That is part 1 of part B. Now let's move on to part 2 of part B. Now part 2 says that given that alpha squared plus beta squared equals 61 over 4, use the expressions in BI to determine the value of k. And those expressions that they're referring to are these. So we're supposed to use these expressions together with the fact that this information we're given, alpha squared plus beta squared equals 61 over 4. And we're supposed to use those to obtain or determine the value of k. Now pay close attention if you notice it says the value of k, which would suggest that we're supposed to get a single value, not more than one, but a single value, right? And of course, you have to go back to this condition here, where we're specifically told that k is an element of the set of whole numbers, right? So let's bear that in mind. Good. Now let's proceed. Now this is what we're given. We're given that alpha squared plus beta squared equals 61 over 4. So this is what we're given. So we're given that alpha squared plus beta squared is equal to 61 over 4. Now, we do not know the value of alpha. We do not know the value of beta. So how do we obtain alpha squared plus beta squared? I mean, from past questions, we would have gotten this, that if you have, for instance, alpha plus beta all squared, which of course is equal to alpha plus beta times alpha plus beta, then this is going to give us alpha times alpha, that's alpha squared, alpha times beta, that's beta squared, sorry, alpha beta rather. Then of course we have beta times alpha. Multiplication is commutative, so alpha beta is equal to beta alpha, so we'll just write down alpha beta. And then lastly, beta times beta gives us beta squared. And so what this therefore shows is that alpha plus beta all squared is equal to alpha squared plus 2 alpha beta plus beta squared. And this further implies that alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. And so this is the expression for alpha squared plus beta squared. All right. So let's proceed. Above, we have an expression for alpha plus beta, and we also have an expression for alpha beta. So let's just use those expressions now to put it into this thing here, right? So let's go ahead and do that. So we have alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. And this is going to be giving us, so let's go ahead, alpha plus beta equals minus 1 over k. So now we have, this is equal to minus 1 over k squared, and this is minus 2 times alpha beta, which of course is minus 25 over k. So this is times minus 25 over k. Now when we simplify this, what do we get? We simply get 1 over k squared plus, because that minus 2 will multiply this minus 25 to give us plus 50 over k. Now we can proceed and essentially express this as a single fraction. So let's do that. So we draw a line underneath, and the common denominator would of course be k squared. We put that down. We say k squared into itself, that goes 1. 1 times 1 is 1, back our plus sign. Then we say k into k squared, that goes k times 50 is 50k. And so therefore what we have for this expression is alpha squared plus beta squared is equal to, let's write it as 50k plus 1 divided by k squared. Right? So we're good so far. Now let's go back now to the information that we're given. So this is what we're given. We are given that alpha squared plus beta squared is equal to 61 over 4. And using the expressions we obtained from part B1, we have gotten that alpha squared plus beta squared is equal to 50k plus 1 over k squared. And therefore, what this means is that if we want to find the value of k, we must equate those. And so we come across here and we say that 50k plus 1 over k squared is equal to 61 over 4. And what do we now do? We basically cross multiply and we try to solve for k. Now remember that whenever we cross multiply, we multiply the numerator of one fraction by the denominator of the other. And that is what we do when we cross multiply. So therefore, what this gives us is that 61 k squared is equal to 4 times 50k plus 1. And we'll proceed. So continuing from here, we now see that 61k squared is equal to 4 times 50, that's 200. So 200k plus, that's 50k plus 1. Yeah, 200k plus 4. And of course, we bring all the terms to one side. And so we get that 61 k squared minus 200k minus 4 is equal to 0. And what type of equation does this resemble? It surely resembles a quadratic. Now let's check this quadratic, and of course let's compare it to the standard quadratic equation. Let's call this ak squared plus bk plus c equals 0. So we see that a is equal to 61, b is equal to negative 200, and c is equal to negative 4. Now, usually, when we have small, nice numbers, we try to find the product AC, and of course, we try to find the factors of AC, which also add to give B, and we try to factorize. But these numbers are not so small and not so nice, so we're not going to even try to factorize this, right? Let's proceed by trying to use a quadratic formula. Now, according to the quadratic formula, we have x equals minus b plus or minus root of b squared minus 4ac all over 2a. All right? And where do we go from here? We substitute the values of a, b, and c into the quadratic formula and we try to solve. Well, in this case, we're not solving for x or solving for k, right? Because you're accustomed to using the formula to solve for x. So let's write that as k equal to that, all right? So let's proceed and see what this will give us. So we say that k, so work with me now, b is equal to minus 200. So therefore, minus b is minus 200. And we have plus or minus the square root of, now b squared, that is negative 200 squared. And now we have minus 4 times a, which is 61, times c, which is negative 4. And all of this is over 2 times a, where a is 61. So this is 2 times 61. Now, bear in mind that we're told at the beginning of the question that k belong to the set of whole numbers. So, which basically means that if you're in an exam and you're given that piece of information, when you're solving for k, you'd have been expected to find k to be a whole number, right? But what happens if k is not working out to be a whole number? Well, let's see what k works out to give. So, continuing from here, we see that k is equal to 200 plus or minus the square root of. Now, what is minus 200 squared? That looks like 40,000. So we have 40,000. Now here we have negative 4 times negative 4 to give us a positive 16. And then positive 16 times 61. See what that gives us. So 16 times 61, right? So 16 times 61. That gives us 976. So this is 4,000 plus 976, right? So yeah, it's a little bit long. So therefore this is root of 40,000 plus 976 all over 122. All right, so we continue. And so this is going to give us, change the color a little bit. See that k is equal to 200 plus or minus the square root of 40,976. And of course, we're hoping that this gives us a nice integer. But let's just check. Square root of 40,976. It does not give a whole number, right? So it does not give a whole number. What we get is k is equal to 200 plus or minus. Now the square root of 4976, approximately 202, well, 202.4 to 1 decimal place. And of course, dividing all of that by 122. So obviously, if you're in the exam and you worked as carefully as you possibly could, and you got to this stage where you found that k is not going to give you a whole number, and you go back to the front of the question, you see that, hey, they said that k is a whole number. You probably will be there thinking, I must have made a mistake somewhere. And you'll be there trying to find that mistake feverishly. And of course, you might just end up wasting a lot of time trying to find a mistake which does not exist, right? So, CXC needs to do better. So let's continue. So we get k is equal to 200 plus 202.4 all over 122, which gives us 402.4 divided by 122. And this actually gives us, let us see, so plus 200 divided by 122, and this gives us approximately 3.3. So to one decimal place, k is equal to 3.3. And the other possible value of k, right, would be equal to k equals 200 minus 202.4 divided by 122. And so this gives us minus 2.4 divided by 122, which gives us, now let me check that. So 2.4 divided by 122, and that's approximately, well, 0.02 to one significant figure or two decimal places. So k is equal to 0.02. So once again, we're specifically told that k belongs to the set of whole numbers, and we're asked to find the value of k. And what we've seen is that neither of our two values has worked out to be whole numbers, right? I mean, you could say if you were to round it to say one significant figure, then 3.3 would be 3, which is a whole number, and 0.02 would basically be 0. But, I mean, based on this question, then what would have been expected to get is actually a whole number for the value of k. But clearly, that is not the case. All right? So that was that part of the question there. Okay? Now, let's look at the next part. Let me just copy this part here and just bring it down. I just realized I could have just copy and paste. But anyways, let's look at this next part of the question. This is the last part of this question, part C. Now, part C says, for the quadratic function g of x, let's write it down. G of x equals, what's that? Minus 5x squared minus 4x plus 2. Determine the exact value of the maximum point and the range using the method of completing the square or otherwise. So they basically tell us that we are supposed to determine the value of the maximum point, all right, so the maximum point or the value or the maximum value rather typically refers to the y value at the turning point. And based on the fact that this quadratic has a being negative, so of course remember that this is equal to ax squared plus bx plus c. And clearly we see that a is equal to negative 5. And this therefore means a quadratic will shape like this, shaped like a frown. All right, so it's going to open downwards. It's going to have a maximum point, and this point is really the value that we want us to find. Well, we could find the x and the y coordinate, right? So how do we go about doing this? Well, the tell us that we can either use the method of completing the square or otherwise. So let's first use the otherwise method. Now, from our knowledge of quadratic equations, we're supposed to know that the turning point occurs where x is equal to minus b over 2a. So for any quadratic function, the turning point occurs where x equals minus b over 2a. Now if we go back over here, we see that, well, we know that a is equal to minus 5, b is equal to negative 4, and c is equal to 2. And so what this means is that the turning point occurs where x equals minus 4 over 2 times minus 5, which gives us, that's 4 over minus 10, 4 over minus 10, right? So minus b over 2a, right? So 4 over minus 10, which we simplify to give minus 2/5. And so that basically is the x coordinate of the turning point. If you want to find the y coordinate, then we simply say that g of minus 2/5. So g of minus 2/5 is equal to minus 5 times minus 2 over 5 squared minus 4 times minus 2 over 5. Then we have plus 2. Now minus 2 over 5 squared, that gives us 4 over 25. So we basically get 4 over 25 times minus 5, which is minus 20 over 25. Then we have minus 4 times minus 2, which is plus 8 over 5. And then we have plus 2. Now for the purpose of addition, we're going to write this as minus 20 over 25. 8 over 5 is the same thing as 40 over 25. So what we did there, multiply both numerator and denominator by 5. And then this now 2 will be equal to 50 over 25. And so in combining those, what do we get? We get minus 20 plus 40. That gives us 20 plus 50, which is 70 over 25, which we can then simplify to give us 14 over 5. And so the turning point would be, so the turning point, which of course is a maximum point, would be the coordinates, or the point with coordinates negative 2 over 5, 14 over 5. And so therefore, there we have the turning point, and the value at the maximum point, or the maximum value, of course, we say that the maximum value would be equal to 14 over 5, right? So that is our method there, or our otherwise method. But of course, as I said, we could also complete the square, and let's go ahead and use completing the square. So g of x equals minus 5x squared minus 4x plus 2. Let's do that one. So we have g of x equals minus 5x squared minus 4x plus 2. Now, whenever we are required to complete the square, in order to complete the square, the coefficient of x squared must be equal to 1. So once again, we see that a is equal to negative 5. And therefore, before we can proceed to completing the square, we must do some factoring. We must factor out the minus 5. We can do one of two things, however. We can factor the minus 5 out of the entire quadratic, or, as I like to do, I prefer to factor it out of just the first two terms, right? So I will say this, that g of x is equal to negative 5. I will open a square bracket, and inside I will get now x squared. Now we're factoring out minus 5, which means that inside we're dividing through by minus 5. And so negative 4 divided by negative 5 becomes plus 4 over 5x. What I will do, I will leave some space inside that square bracket, and I will put my plus 2 outside, right? Now, let's examine the expression inside the square bracket. We have x squared plus 4 over 5x. And of course, you see that the coefficient of x squared is now equal to 1. And of course, this is our x term where b is equal to 4 over 5. So b is equal to 4 over 5. Now, whenever we're required to complete the square, it involves adding a half of b squared. So if b is equal to 4 over 5, then we say that b over 2 is equal to 4 over 2 times 5, which of course gives us 2 over 5. And of course, we'll add that squared. So say plus 2 over 5 squared. But by adding that to the square bracket, the overall expression will change. And so therefore, to negate that change, we must also subtract 2 over 5 squared. So essentially, those will cancel each other and do not change the polynomial. But by including them, we're going to be allowed to express this quadratic in a given form, right? Now, having done that, what usually happens is this. These first three terms inside here form what we call our perfect square, right? So the first three terms form our perfect square. Now let's proceed. So what we have is this. We have g of x is equal to minus 5, and I'll keep my square bracket. But now I'm going to put this in a different form. And so this now becomes x plus 2 over 5, and we see that we have our perfect square. Let me change the color. So x plus 2 over 5. So this is, what color should I use? Let me use green. No, let me keep it yellow, not to avoid confusion. So x plus 2 over 5. So this term, that becomes x plus 2 over 5 squared. So these first three terms that we highlighted as a perfect square is what gives us that. So that becomes our perfect square. And of course, if we were to multiply out x plus 5 all squared, this is what we get. X squared plus 4 over 5x plus, well, 2 over 5 squared, same thing as 4 over 25. All right? Yes. And so we have our minus, now we expand this out. 2/5, that minus 4 over 25, and we can now close our square bracket. But of course, we must remember that we have 2 on the outside, so we must keep our plus 2. And now what we do is we expand out by multiplying the terms inside the square bracket by our -5. And so this gives us g of x equals -5 bracket x plus 2 over 5 squared. And then we have now minus 5 times minus 4 over 25. That gives us plus 20 over 25 plus 2. And we proceed, right? And so what this gives us is that g of x equals minus 5 times x plus 2 over 5 squared. And this, of course, this 20 over 25, we can simplify that. 20 over 25, that's the same thing as 4 over 5. So plus 4 over 5. And then the 2 as a fraction, that will be plus 10 over 5. And so we've gotten g of x is equal to minus 5 bracket x plus 2 over 5 all squared plus 14 over 5. And of course, if we do a quick comparison with the value we got from before, what did we get? We got that our x-coordinate of the turning point is minus 2/5, and the y-coordinate, of course, is 14 over 5. So this is what completing the square allows us to do. It allows us to basically just read off the turning point of the quadratic. And of course, the x-coordinate occurs where this expression inside the bracket equals 0. So when we set x plus 2 over 5 equals 0, it means x is equal to minus 2 over 5, right? So x plus 2 over 5 equals 0. So x equals negative 2 over 5. That is the x-coordinate of the turning point. And of course, our y-coordinate is this number over here by itself. All right, so once again, the maximum point, of course, will have coordinates minus 2/5, 14 over 5, which of course is the same exact thing that we'd have gotten before. All right, so this is a completion of question 1, which of course wasn't without its problems. We're specifically told that the value of k was a member of the set of whole numbers. And of course, as we just saw, k did not work out to be a whole number. All right. So this is the end of question 1, and of course in subsequent videos I'll be looking at the solution to the other questions from CSEC Admaths of 2024.